Close your eyes for a moment. Imagine the night sky above you. It is a canvas of absolute black, sprinkled with millions of tiny, glittering diamonds. From our small, safe vantage point here on Earth, these stars look incredibly peaceful. They look so small, you could reach out and cover 1,000 of them with just the tip of your finger. But this is the universe's greatest illusion. The cosmos is not a quiet painting. It is a boundless ocean of terrifying, majestic fire. Today we are going to embark on a journey that will challenge everything you think you know about size, scale, and our place in the dark. We are going to leave the comfort of our home planet. We are going to fly past our sun, a star that gives us life, yet is nothing more than a microscopic speck of cosmic dust compared to what awaits us in the deep. We are going to travel to the very edge of human comprehension, to stand in the shadow of a true cosmic titan, a star so unbelievably massive, so overwhelmingly colossal, that the human brain simply cannot process its true dimensions without breaking them down. Breathe deeply. Let go of your earthly worries. They do not matter out here. You are about to experience the terrifyingly beautiful truth about the biggest star in the known universe. Are you ready to feel the weight of infinity? Before we can truly understand the sheer magnitude of the universe's largest stars, we must first adjust the way our minds process space. Down here on Earth, we measure things in miles, in kilometers, in hours and in days. But out here, in the vast, echoing silence of the void, these human measurements are completely useless. They are too small, too fragile. Instead, we must use the ultimate speed limit of reality itself, the speed of light. Light travels at an astounding 186,000 miles per second. In the time it takes you to blink, light has circled the entire Earth 7 times. It is the fastest thing in existence, and yet the universe is so sprawling, so incomprehensibly huge, that even light takes years, centuries, or millennia to cross the distances between the stars. When we look up at the night sky, we are not seeing the universe as it is right now. We are looking back in time. We are seeing ancient ghosts of light, and the stars that emit this light come in many different forms. They are born in massive, swirling clouds of interstellar gas and dust called nebulas. Some stars are small, cool and dim, burning slowly for trillions of years. Some are like our sun, perfectly average, burning a steady yellow light. But there is a rare, spectacular breed of stars. These are the giants, the supergiants, the hypergiants. These are stars that burn with such furious intensity that they inflate like colossal balloons of plasma. They do not just live, they roar against the darkness. To understand the king of them all, we must first learn to walk among the giants. Let us begin our ascent. Our journey begins at home. Imagine standing on a grassy field, looking up at the midday sun. It dominates the sky. It warms your skin. It is the undisputed master of our solar system. The sun is incredibly large compared to Earth. You could fit 1 million Earths inside of it. Think about that for a moment. 1 million planets, with all their oceans, mountains, cities, and billions of people, easily swallowed by this single sphere of burning hydrogen. It feels enormous. But this is where our illusion shatters. The sun is an average star, a yellow dwarf. Out here in the cosmos, it is nothing. It is a mere spark. Leaving the solar system. We ignite our imaginary engines and drift away from the sun. We fly past Mars, past the swirling gas storms of Jupiter, and past the beautiful icy rings of Saturn. We pass the Voyager probes, the farthest human-made objects ever sent into the dark. The sun is shrinking behind us. It becomes just another bright star in the endless sea of black. We are now in the interstellar medium, where the space between stars is so cold, so empty, that time itself feels frozen. We are heading toward the brightest star in our night sky, Sirius. Let us see how our Sun measures up to its neighbours. Meeting the dog star. Here we are at Sirius, located just 8.6 light-years away from Earth. It shines brilliantly, a piercing white-blue diamond in the dark. Sirius is a main sequence star, like our Sun, but it is roughly twice as massive and 25 times more luminous. If Sirius replaced our Sun, Earth's oceans would instantly boil away. The sky would be blindingly white. Here, our million-Earth Sun starts to look just a little bit smaller. But Sirius is still just a localized giant. We must travel further, deeper into the Milky Way, to find the true monsters of the cosmos. The orange giant awakens. We leap across the void, traveling 34 light-years from home, arriving at Pollux. This is an orange giant star. It has exhausted the hydrogen at its core and has begun to expand. This is the fate that awaits our own Sun billions of years from now. Pollux is 9 times wider than our Sun. Imagine looking up at the sky on Earth and instead of a small yellow disk, you see a massive, looming, fiery orange orb taking up a massive chunk of the horizon. It is beautiful, yet deeply intimidating. But Pollux is just a stepping stone on our journey to the impossible. The Bear Watcher. Further still, we glide to Arcturus, a glowing red giant located 36 light-years away. Arcturus is 25 times larger than our Sun. If you placed Arcturus at the center of our solar system, it would stretch halfway to the orbit of Mercury. It is a stellar behemoth, burning with an intense rusty red light. The heat radiating from it is intense, a slow, dying fire. Arcturus is old, and it is large. It shows us how stars swell up as they age. Yet in the grand scheme of cosmic architecture, Arcturus is still considered somewhat modest. The real giants are waiting in the shadows. The Eye of the Bull. We now travel 65 light-years away to Aldebaran, the fiery red eye of the Taurus constellation. Aldebaran is a red giant that has swollen to 44 times the diameter of our Sun. Let that sink in. 44 suns lined up edge to edge just across its face. The sheer volume of this star is staggering. If our Sun were the size of a tiny marble, Aldebaran would be a large beach ball. The energy pouring off of it is immense. But still, the universe laughs at this scale. Aldebaran is big, but it is not a supergiant. To find those, we must travel hundreds of light-years away. The Blue Hunter. Suddenly, the darkness is pierced by an intense, brilliant blue light. We have arrived at Rigel, the brightest star in the constellation Orion, located about 860 light-years from Earth. Rigel is a blue supergiant. It is 79 times wider than our Sun, but it is its luminosity that is truly terrifying. Rigel shines roughly 120,000 times brighter than our Sun. It burns fast, hot, and violent. It is a cosmic furnace of unimaginable power. If Rigel were our Sun, life on Earth would be impossible. The sheer radiation would sterilize the entire solar system. The red shoulder of Orion. But just across the constellation of Orion lies a star that dwarfs even Rigel. We fly toward Betelgeuse. This is a red supergiant. The scale here jumps dramatically. Betelgeuse is not twice as big as our Sun. It is not 10 times as big. Betelgeuse is nearly 700 times larger than our Sun. If you dropped Betelgeuse into the center of our solar system, it would swallow Mercury. It would swallow Venus. It would swallow Earth and Mars and stretch all the way out to the asteroid belt. Our home planet would be incinerated deep within the crushing, burning atmosphere of this star. The myth of solid stars. But here we must break a common myth. When we imagine these giant stars, we often picture them as solid, hard spheres of fire, like a glowing bowling ball. But Betelgeuse is not like that. A red supergiant is more like a massive, glowing, chaotic cloud of extremely hot vacuum. Its outer edges are incredibly thin, almost ghost-like. It pulsates, it breathes, it changes shape as massive bubbles of hot plasma, some the size of our entire solar system, boil up to the surface and sink back down. It is a living, turbulent ocean of gas, held together only by its own immense gravity. The heart of the Scorpion. Leaving Orion, we travel to the constellation Scorpius to visit Antares. This is another red supergiant, similar in size to Betelgeuse, but perhaps even larger, stretching up to 800 times the width of our Sun. Antares glows with a deep, blood-red hue. It is so massive that the light from its core takes hours just to reach its own surface. Imagine flying a spaceship at the speed of light, a speed that could circle the Earth 7 times in a second, and it would still take you over an hour to cross from one side of Antares to the other. Herschel's Garnet Star. Let us push deeper into the abyss. We travel towards the constellation Cepheus to a star named Mu Cephei. William Herschel, a famous astronomer, described it as having a deep garnet color, and the name stuck. Mu Cephei is a red supergiant that is roughly 1,000 times larger than our Sun. 1,000. Now, our Sun, which could hold 1,000,000 Earths, is reduced to a microscopic speck of dust floating next to a towering mountain. If you placed Mu Cephei in our solar system, it would swallow the orbit of Jupiter. The gas giant planet would simply cease to exist, vaporized in an instant. The Cepheus Giants. In the same constellation, we find even more terrifying neighbors. 354 Cephei and VV Cephei A. Both of these stars easily exceed 1,000 times the radius of our Sun. They are so ridiculously massive that astronomers have a hard time exactly pinpointing where the star ends and where empty space begins. Because these stars are shedding mass continuously, they are surrounded by thick, opaque clouds of their own dying dust. It is like trying to measure the size of a cloud in a fog storm. But regardless of the exact edge, their size is undisputed. They are cosmic leviathans. The former king, Vi Canis Majoris. For a long time, humanity thought they had found the absolute limit, a star located in the constellation Canis Major. Its name is VY Canis Majoris. When astronomers first measured it, they were stunned. They estimated it to be over 2,000 times the radius of the Sun. Later measurements refined this to about 1,420 times the Sun's radius. Even at this reduced estimate, VY Canis Majoris is an absolute monster. It is a hypergiant star shedding its mass so violently that it has created a massive nebula of its own material around itself. Flight around the giant. Let us try to imagine the scale of VY Canis Majoris with a simple thought experiment. Imagine you are sitting in a commercial passenger jet, flying at a cruising speed of 900 kilometers per hour. If you flew that plane around the Earth, it would take you about 2 days. If you flew that same plane around our Sun, it would take you about 7 months. But if you were to fly a passenger jet around the equator of VY Canis Majoris, it would take you 1,100 years. A journey spanning a millennium just to circle a single star once. The reign of UY Scuti. But space is vast, and our telescopes are always improving. Soon, VY Canis Majoris was dethroned. Deep in the constellation of Scutum, we found UY Scuti. For several years, UY Scuti held the title of the largest known star in the universe. It was estimated to be around 1,700 times the radius of our Sun. If placed in our solar system, its atmosphere would engulf Jupiter and reach outward toward the orbit of Saturn. UY Scuti is so massive, yet so incredibly bright, shining 340,000 times brighter than our Sun. It was the unquestioned king. The fading of a titan. But science is a process of constant discovery. As we studied UY Scuti more closely, utilizing the advanced data from the Gaia Space Observatory, we realized we had made an error. The thick dust clouds surrounding UY Scuti had tricked our sensors. When we recalculated its distance and size, UY Scuti shrank. It is still a colossal supergiant, perhaps around 900 times the size of the Sun, but it was no longer the record holder. The throne was empty once more. The universe was waiting for a new champion to take the crown. Journey to the Scutum Centaurus arm. To find the true king, we must travel incredibly far from home. We are heading 20,000 light-years away from Earth. We are flying deep into the Scutum Centaurus arm of the Milky Way galaxy. Here, hidden within a massive cluster of stars known as the Stephenson 2 cluster, resides a group of red supergiants. It is a celestial gathering of titans. The stellar winds here are fierce, the radiation is lethal, but amidst this chaotic, beautiful stellar nursery, one object stands out. One star that defies all logic. Behold the king, Stephenson 2:18. And here it is, emerging from the cosmic dust like an ancient deity of fire. Stephenson 2:18, the current record holder for the largest known star in the entire universe. As we drift toward it, the mind struggles to process what the eyes are seeing. It is a red supergiant, but that term feels completely inadequate. It is a star of such monstrous proportions that it breaks the very scale we have been using to measure everything else. Breathe in the silence of space. Prepare your mind for the true geometry of the infinite, the absolute mathematics of scale. Let us look at the numbers. Stephenson 2:18 has an estimated radius of 2,150 times that of our Sun. The number is easy to say, but impossible to visualize. If our Sun was exactly 1 inch wide, about the size of a quarter, Stephenson 2:18 would be a glowing sphere of fire 180 feet across. That is the height of an 18-story building, from a tiny coin to a towering skyscraper. And remember, that tiny coin is a star that can already hold 1,000,000 Earths. Swallowing the solar system. Let us play our favorite game of cosmic placement. We take Stephenson 2-18 and we drop it into the exact center of our solar system, replacing our Sun. What happens? Mercury is gone. Venus is gone. Earth, our beautiful blue marble, is instantly vaporized into atoms. Mars is swallowed. The asteroid belt is consumed. Jupiter, the giant of our system, disappears. Saturn, with all its majestic rings, is engulfed. The edge of this monstrous star would stretch out entirely past the orbit of Saturn, reaching into the frozen wastelands of the outer solar system. It is a single star, the size of a solar system. The volume of infinity. When we talk about radius, we are only talking about the distance from the center to the edge. But what about volume? What about the actual 3D space inside this titan? The volume of a sphere increases by the cube of its radius. Because Stephenson 2-18 is 2,150 times wider than the Sun, its volume is nearly 10 billion times greater. 10 billion suns could fit inside Stephenson 2-18. And remember, 1,000,000 Earths fit inside one Sun. The number of Earths that could fit inside this star is 10 quadrillion. A number so large, it loses all human meaning. The speed of light fails. Let us return to our ultimate cosmic speed limit, the speed of light. Light travels at 186,000 miles per second. It takes light just 8 minutes to travel from our Sun to the Earth. But Stephenson 2-18 is so gargantuan that if a photon of light were emitted from one side of its equator, it would take nearly 9 hours to travel all the way around the star and reach the other side. Think about that. Light, the fastest entity in the physical universe, takes a full working day just to circle this star once. The airplane journey revisited. And what about our imaginary commercial airplane? Flying at 900 kilometers per hour. To circle our Sun, it took 7 months. to circle VY Canis Majoris, it took 1,100 years. If you boarded a plane today to fly around the equator of Stephenson 218, the journey would take you nearly 3,000 years. If your flight began during the ancient days of the Roman Empire, you would only just be landing back at your starting point today. Generations would live and die on that plane just to trace the outline of a single star. The illusion of density. But here is the most fascinating, mind-bending secret about Stephenson 218. Despite its terrifying size, it is incredibly fragile. We tend to think that bigger means heavier, denser, more solid. But the opposite is true. Stephenson 218 only has roughly 15 to 20 times the mass of our Sun. All that mass is stretched out, inflated, pushed to the absolute breaking point. The outer layers of this star are so thin, so diffuse, that they are actually less dense than the vacuum of a laboratory chamber on Earth. It is a star made of fiery, glowing nothingness. A ghostly phenomenon. If you were somehow able to fly a heavily shielded spacecraft right into the outer edge of Stephenson 218, you wouldn't crash into a fiery wall. You wouldn't even realize you had entered the star at first. The gas is so spread out that it would feel like flying through a slightly warm, incredibly thin mist. You would have to fly millions of miles deep into the star before the gas became thick enough to slow your ship down. It is a cosmic ghost, a phantom giant burning brightly in the void. The inevitable collapse. What does the future hold for a monster like this? A star this massive lives on borrowed time. Our tiny sun will live for 10 billion years, burning fuel slowly and efficiently. But Stephenson 218 is a cosmic gas guzzler. It burns its nuclear fuel at a terrifying rate. It is racing toward its own destruction. Within the next few million years, a blink of an eye in cosmic time, Stephenson 218 will completely run out of fuel. The outward pressure of its nuclear fusion will stop, and the immense gravity of its core will take over. The supernova event. When that moment comes, the entire star will collapse inward upon itself at a significant fraction of the speed of light. All that mass, all that gas, crushing down into a tiny, infinitely dense point. And then it will rebound. The resulting explosion will be a supernova. It will be one of the most violent, energetic events in the universe. For a brief moment, a few weeks or months, the death of this single star will outshine the entire Milky Way galaxy. It will release more energy in a second than our Sun will in its entire 10 billion year lifespan. The aftermath. When the blinding light of the supernova finally fades, what will be left of the mighty king? The outer layers of the star will be blasted out into deep space, creating a beautiful, expanding cloud of glowing gas and stardust, a nebula. This dust will eventually clump together over millions of years to form new planets, new moons, and perhaps eventually new life. The giant will have sacrificed itself to seed the universe with the heavy elements required for creation. Everything in your body, the iron in your blood, was forged in the death of a star just like this. The black hole. And at the very center of that expanding nebula, where the mighty core of Stephenson 218 once burned, something terrifying will remain. The core will have collapsed so violently that not even atoms can withstand the pressure. It will tear a hole in the fabric of space and time itself. The largest star in the universe will end its life by becoming a black hole, an object of infinite gravity from which not even light can escape. From the brightest, most expansive object imaginable to a point of absolute crushing darkness. A poetic end to a stellar titan. The beauty of perspective. As we drift back away from Stephenson 218, watching it burn quietly in the distance, we are left with a profound sense of perspective. It is easy to feel insignificant when faced with such incomprehensible scale. If a single star can be this large, how small are we? How meaningless are our daily worries? But do not let this scale frighten you. let it comfort you. You are part of this universe. The same physics that govern the mighty Stephenson 218 govern the beating of your heart. We are the universe experiencing itself. We are the cosmos looking back at its own magnificent reflection. Our journey is complete. We turn our imaginary ship around and travel 20,000 light-years back through the dark, cold vacuum of space. We glide back into the familiar arms of the Milky Way, diving back toward that tiny yellow speck of light we call home, the Sun. As we approach, it grows larger, welcoming us back with its gentle, life-giving warmth. It may not be the largest star in the universe, it may not be a supergiant or a hypergiant, but it is perfectly stable, it is perfectly sized, and it is perfectly ours. The sheer scale of the cosmos, the terrifying beauty of monsters like Stephenson 2-18, serves only to remind us of how incredibly lucky we are to exist in this quiet, peaceful corner of space. The universe is a place of extremes, of chaotic fire and silent ice. But here, on our tiny blue dot, we have found balance. Thank you for joining us on this hypnotic journey across the stars. We hope you found peace in the vastness of the cosmos and that your earthly worries have shrunk down to the size of a cosmic grain of sand. If this journey through space brought you comfort and awe, please subscribe to the channel, like this video, and share it with someone who needs to relax. And before you drift off to sleep, leave a comment below. Now that you know how huge these stars can be, what is your favorite star in the night sky? Rest well, space travelers. The universe is watching over you.